In this video, I will teach you about similar triangle postulates and theorems. And the bottom line is there are only three ways to prove that two triangles are similar. There is side-side-side similarity, side-angle-side similarity, and angle-angle similarity. And I will show you what those mean as we go along. So looking at problem number 1, are the triangles similar, yes or no? Well, let's start by finding the missing angle for each triangle. We know that the sum of the angles in a triangle has to add up to 180. So if I take 180 and I subtract the two angles that we are given, so minus 50 minus 79, so that gives me 51. So I know that this angle is going to be 51. And I'm noticing over here we have 51 and 79, just like this is 51 and 79. So you know the other angle is going to have to be 50. So this is enough to prove that the triangles are similar, yes, because angle-angle means that you have to have two pairs of congruent angles to prove that the triangles are similar. And here we have three pairs of congruent angles, and we only needed two. So the triangles will be similar by angle-angle similarity. And let's go ahead and make our similarity statement. Triangle ABC is similar to triangle. Let's see. The A corresponds with D, right? Because they're both 79. B corresponds with F, and that just leaves E. All right, so that's it for problem number 1. How about problem number 2? Are these triangles going to be similar? Well, all we have is we have two pairs of sides. So that's not going to be enough information for side-side-side similarity. We need three pairs of sides, and we would be checking to see if they were proportional. But we don't have three pairs of sides marked, so our only hope is for side-angle side. But for that, we would need to somehow know that angle B is congruent to angle F. We'd need the angle in the middle. So we just don't have enough information. So we're going to have to say no. Okay, we don't have enough information to prove that these triangles are similar. So I'm just going to say not enough information. Okay, let's move on to problem number 3. Okay, we can see that angle B is congruent to angle E. We also know that this angle is congruent to this angle. Angle ACB is congruent to angle DCE because these are vertical angles, and vertical angles are always equal. Well, that gives us two angles, two pairs of congruent angles. So that means we have angle-angle similarity. And we can go ahead and say that triangle ABC is similar to triangle DEC. So that was a yes. Okay, how about number 4? Are these triangles similar? Well, there's a chance that they will be similar by side-side-side similarity. I see that we have all three sides with lengths shown. Now, when we are dealing with congruent triangles, these S's would mean that we have pairs of congruent sides. So obviously, this triangle on the right is smaller, so the lengths are smaller. So when we are talking about similarity, the S's don't mean that the sides are congruent. The S's mean that the sides are proportional. Proportional means that you will get the same scale factor over and over again if you make little fractions, little ratios out of corresponding sides. So the first thing is to decide which sides are corresponding. And here's what I like to do. Look at the first triangle. What is the shortest side on the first triangle? Well, that's going to be 25. What is the smallest side on the second triangle? That's going to be 20. That means if these triangles turn out to be similar, these would have to be the corresponding sides. Now let's switch for the biggest. 50 is the biggest on this triangle. 40 is the biggest on this triangle, so those would be corresponding if these triangles are similar at all. That leaves the 45 and the 36 to be corresponding. To figure out whether or not these corresponding sides are proportional, we need to make little fractions out of them. I like to label the triangles as new and old. It doesn't really matter which one you call new and which one you call old. I'm going to call this one the new triangle, and I'm going to call this one the old triangle. The only point of doing that is it will help me keep track if I make all of my ratios in the form new over old. So I'm just going to put this up here as a reminder that we're going to go new over old over and over again. So, for example, if you look at the yellow sides, so if we go new over old, that would be 20 over 25. What does that reduce down to? Well, both of these are divisible by 5. And if I divide both of these by 5, I'm going to get 4 over 5. Now, if that is not obvious and very clear to you, you can use your TI-30XS multi-view to reduce for you. So just keep in mind, if you do 20 over 25, the calculator will reduce that for you. So let's do that 2 more times. How about the greens? Okay, new over old, remember. So I'm going to do 36 over 45. Okay, both of these are divisible by 9. And I can tell that if I divide both of these by 9, I'm going to get 4 over 5. Again, let's put it in the calculator though. 36 over 45. All right, there's 4/5 again. So let's do one more. Let's do this blue pair. Okay, new over old. So we're going to do 40 over 50. If you divide both of these by 10, obviously you're going to get 4 over 5. So notice that we are getting the same scale factor every time. That means that these 3 pairs of sides are all proportional. So this will be side, side, side similarity. And we can go ahead and match up the corresponding sides. Well, let's match up the corresponding angles and say triangle ABC is similar to triangle. And here's what I like to do. So angle A is here between the yellow and the blue. So that's going to correspond with angle E. Next, we have angle B. Notice angle B is between the yellow and the green. So that's going to correspond with angle F. And that just leaves angle D. All right, so that was number 4. In number 5, we are told that we can prove that these triangles are similar. So let's go ahead and fill in the blanks. I'm going to actually decide the reason first. We are given that angle A is congruent to angle E. We can also note that this angle is congruent to this angle because these are vertical angles. That gives us 2 pairs of congruent angles. So these triangles will be similar by angle-angle similarity. And we can go ahead and say that triangle ABC is similar to triangle EDC by angle-angle similarity. Now, label the diagram with the info given below. Then find all angle measures and side lengths. So let's see, we are told that angle A is 81 degrees, so I'm just going to put 81 right there. And we are told that angle DCE, that's right here, so this is 43 degrees. And we need to find everything else that we can. So based on that, if we have 43 degrees here on the right, then the other vertical angle will also be 43 degrees. And that gives us 2 out of 3 angles on the left triangle. So we can go ahead and subtract from 180. So 180 minus 81 minus 43. 56. So that means that angle B right here is 56. And so that corresponds with angle D, so that means this is also 56. And we already knew that angle A was congruent to angle E, so that means this is 81. So let's look back and fill in all of these angles. Angle B is 56. And angle D is also 56 degrees. Angle E is 81 degrees. Angle ACB. ACB is this 43 degrees on the left. And there you have it. So now let's talk about the sides. I think I'll switch colors to keep it clear. AB is 16. So this is 16 right here. Okay, CD is 18. BC is 24. And EC is 15. Okay, let's match up the corresponding sides. So you can tell that these are basically mirror images of each other. Even though this one is smaller, you can see that they are sort of reflected. So I know that, for example, the 24 and the 18, those are clearly corresponding sides. And we know that the 16 is going to correspond with ED over here. And we know that the 15 is going to correspond with AC right here. So now we've matched up all the corresponding sides. So if I want to find side CA, for example, okay, so side CA is right here. I'm going to put an X on that. So I'm going to do my work now. So I'm going to set up a fraction. I'm going to make sure I match up the like colors because those are corresponding sides. So I can say X over 15, for example. Now I need to pick another pair of corresponding sides to make an equal fraction. I'm noticing that the blues, one of those are empty, so I'm not going to use the blues. I'm going to use the yellows, and I'm going to go in the same order. So I went X over 15, so now I will do 24 over 18. So 24 over 18. So let's go ahead and solve this equation. So I will have X over 15 and 24 over 18. Let's reduce that. Both of these are divisible by 6. So this should turn out to be 4 over 3. But remember, if you're not completely comfortable with that, you can just do 24 over 18 right in your calculator and get the same thing. So you probably know that it's time to cross multiply right now. So if I do this diagonal, that's going to give me 3x. And then if I do this diagonal, that's going to be 60. So I have 3x is equal to 60. And then if I divide both sides by 3, that gives me x is equal to 20. So remember that x is really side CA. So side CA is 20. All right, let's now find DE. Okay, so side DE is right here. I'm going to call that y. So it's time to set up a new equation involving y. I'm going to change colors here. So I'll do y over 16. So I could do y over 16. Okay, that's blue over blue. So now I need another fraction, and I could use the greens, especially now that I know that x is 20. I could do 15 over 20, but I encourage you not to use a value that you just found. What if you made a mistake? If you use that number that you just found, now you're going to get 2 problems wrong instead of just 1. So it's better to use numbers that you were given from the start. So I will say y over 16 equals 18 over 24. Okay, 18 over 24. Notice I have to go in the same order. If I do y over 16, that's sort of right over left. Then I have to do 18 over 24. I need to do right over left again. Anyway, let's simplify this down. I'm running out of space a little bit, but 18 over 24, of course this will reduce down to 3 over 4 because you see what happened last time. So this will be the same thing as y over 16 equals 3 over 4. Okay, so it's time to cross multiply. If I do this diagonal, that's going to be 4y. And then if I do the other diagonal, I think that's 48. And then if we divide both sides by 4, that's going to be 12. So y is equal to 12. But remember that y is side DE. So side DE is 12. Last problem. We can prove that these triangles are similar. We just have to fill in the blanks. Well, let's start by figuring out why these triangles are similar. So one thing is, first of all, please understand the 2 triangles that we are talking about. We have a triangle right here, all right, a smaller triangle, and then we have a larger triangle right here, like this. Okay, so just keep that in your head. We have the small triangle and then the big triangle. Those are the 2 triangles we are talking about. So this angle is shared by both triangles, all right? Angle C is an angle of the small triangle, but it's also an angle of the bigger triangle. So the 2 triangles have this shared angle in common. So let's go ahead and mark that. In addition to that, I want you to try to visualize a letter F right now. See, I have these parallel sides. So what happens is I have these 2 parallel lines, and this side right here is a transversal. So it forms sort of this F that's lying on its back. I am pointing that out to you because the corners of the F are corresponding angles. And corresponding angles on parallel lines are always congruent. So that means this angle is definitely going to be congruent to this angle. So that actually gives us 2 pairs of congruent angles, the 2 that I just marked. And remember that this angle C really is congruent for both triangles, small and large. So this is angle-angle similarity. I should mention to you that I could have actually drawn the F the other way. So I could have drawn the F like this. So if I wanted to, instead of using the shared angle down here at angle C, I could have said, see, look at the corners of the F here and here. These are also corresponding angles. So this would also give me angle-angle similarity. So there were two ways that you could have done that one. Okay, so either way, we have angle-angle similarity. And now we can say that triangle ABC is similar to triangle, let's see, ABC, and then DEC. So DEC. Label the diagram with the information given and answer all of these questions. My recommendation would actually be to draw these triangles separately. So that's what I'm going to do. All right, so I've drawn the triangle separately. Let's fill in the angles that we are given. So angle EDC is 66 degrees. So let's see, EDC is right here. So I'm going to go ahead and put the 66. Angle B is 87. So angle B is 87. All right, that's all we're given in terms of angles. Let's see what else we can figure out. Well, if angle D is 66, that means angle A will also be 66 because those are corresponding angles. And for similar triangles, the corresponding angles are equal. They're congruent. And in the same way, if angle B is 87, that means that angle E will also be 87. So we can find the missing angle C by subtracting from 180. So 180 minus 87 minus 66, that's 27. Okay, so that's 27 and 27. So let's go back and fill in what we know. Angle A, that was 66 degrees. Angle DEC. DEC, that's the 87 degrees. Angle C is 27. I guess they wrote it twice because it's in both of these positions. So of course those are the same, 27 degrees both times. So that's it for the angles. Now let's go back and talk about the sides. AB is 25. And CD is 30. BC is 45. DE is 15. All right, so we need to find CA, which is down here. I'm going to call this X. Let's go ahead and find that first. I'm not going to bother coloring the sides with the corresponding sides with the matching colors because the triangle is oriented the exact same way. So it's easy to see that the 15, you know what, I changed my mind. I am gonna color it because it's just so easy. Why not? All right, the 30 goes with the X and the 45 goes with whatever this is. Okay, so if I want to solve for X, I definitely need to make a fraction involving the X. So I'm going to do X over 30. Okay, so I'm doing blue over blue. I'm going to set that equal to another fraction. If I do x over 30, then I will do 25 over 15. I have to go in the same order. So 25 over 15. Let's reduce this fraction to keep the numbers small. Both of these are divisible by 5, so this will be 5 over 3. You can use your calculator if you need to. 25 over 15. Cross multiply. So if I do this diagonal and then this diagonal, that's going to give me 3x is equal to 150. Then if I divide both sides by 3, that's going to give me 50. So x is equal to 50, but that means side CA, because that's x, so side CA is 50. Last, we need to find EC. Side EC is right here. Let's go ahead and just call it y. Okay, so we need to make a fraction involving y. So I'm going to do y over 45. So here I go. Y over 45 equals. Let's use the yellows again because we have both numbers. But if I did y over 45, then I must do 15 over 25. You have to go in the same order both times. So 15 over 25. So that means if I reduce this, y over 45 equals 3 over 5. So let's cross multiply. If I do this diagonal and this diagonal, that's going to give me 5y is equal to and then if we divide both sides by 5, that's 27. So y is equal to 27. And remember, y is EC. So that means EC is 27. And that's it.